Hi everyone, I'm Connor Malone and I'm going to be presenting to you today our work on improving road segmentation in challenging domains using similar place priors. Our work uses two perception tasks, semantic segmentation for our road segmentation and visual place recognition for finding similar places. Semantic segmentation is the task of finding pixel-wise class labels across an image. Traditionally, this was achieved using color space analysis and machine learning, but more modern systems use fully convolutional networks and achieve high levels of accuracy in ideal daytime conditions. Visual place recognition, on the other hand, localizes query images in a database of reference images, where typically there's also some sort of appearance or viewpoint shift between their query and reference images. Generally, the methodology used is feature extraction, followed by post-processing and then feature matching. The challenges that are faced in semantic segmentation often revolve around the different conditions that we can perform in. So we can perform well in daytime images, but the networks that we train on these images typically don't generalize to more challenging domains, such as night, rain, and snow. And we have a limited amount of data from these different conditions, so it makes it harder to train for. Some of the existing solutions include fine-tuning, style transfer, and domain adaptation. But these all share some of the same limitations where we need labeled data from a target domain in order to make these improvements. And this can be costly to obtain, label, and train with. And some state-of-the-art approaches, such as map-guided domain adaptation, also require multiple traverses of an area to perform these improvements. Our solution is to use similar places. So we use visual place recognition to find priors which inform our road segmentation. Now, these priors are visually or structurally similar, geographically separate, so they don't correspond to the same location, and they're captured under more ideal conditions for our road segmentation network. Now, we are able to improve our road segmentation using this with no additional or domain-specific training, which means we don't have to have encountered the environment or type of conditions that we're going to be operating in. We also implement it as a post-processing method, so it's network agnostic, and we can apply it to any segmentation or visual place recognition network. The pipeline that we use is we take a query image and a reference pool of places, and we feed these into a visual place recognition network. We then take out the top K visual place recognition matches, which are most similar to our query image. We then take the segmentation output from our similar places and our query segmentation, and we feed this into a Bayesian update. We're then able to extract our updated road predictions. Now, we isolate the updates to only road pixels, so the predictions for the rest of the classes remain largely the same. In our Bayesian update, we set Gaussian distributions over loaded outputs from our segmentation networks, where the prior is parameterized by the similar place segmentations, and the likelihood is parameterized by our query segmentation. We then perform a Bayesian update at all potential road pixels. Some of the key results we found here is that we're able to apply this method to 3 different base networks across multiple conditions and data sets and see improvement on all. And so we were able to show that without any data from the target conditions and/or location, we could make an improvement on these networks. Some of the limitations we found, though, is that when we weren't able to retrieve a similar image, this sometimes resulted in erosion or deterioration of classes next to the road, such as the last row in our qualitative results here. We also found that when the performance was already significantly high, we weren't able to improve this even further. Some of the future work we'd like to do with this is extend it to improve other semantic classes, patch-based similar places, which we've actually already conducted some initial work on, improving visual place recognition methods for similar place retrieval specifically, and then using similar places to improve other perception tasks as well. Thanks for listening.